Since the Chernobyl nuclear power plant explosion in 1986, scientists have been tirelessly studying the region to understand the long-term effects of radiation on the surrounding ecosystem. The disaster released about 5% of the reactor's radioactive core into the environment, devastating the area and forcing the creation of the Chernobyl exclusion zone. While most wildlife has shown signs of recovery, one particular species, the wild boar, has baffled researchers with persistently high levels of radiation in their bodies. This anomaly, known as the wild boar paradox, defies conventional understanding of radioactive decay and ecosystem recovery. The Chernobyl disaster and its aftermath. The Chernobyl disaster was the largest radioactive catastrophe in Europe's history. The meltdown led to the evacuation of humans, but the plants and animals within the exclusion zone remained exposed to high levels of radiation. Over the decades, scientists have closely monitored the area to assess how radiation moves through ecosystems, noting a steady decrease in contamination levels, except for the wild boars. Despite the passage of time and the natural decay of radioactive elements, wild boars continue to carry alarmingly high levels of cesium-137, a radioactive isotope. Understanding radioactive decay and its environmental impact. Radioactive elements decay at a predictable rate known as a half-life. For example, cesium-137, one of the most dangerous isotopes released during the Chernobyl disaster, has a half-life of about 30 years. This means that roughly half of the cesium present should have decayed by now, significantly reducing the contamination levels in the area. However, ecosystems are complex, and the movement of radioactive elements through water, soil, and food chains can delay the reduction of radiation levels. Even so, a downward trend in contamination has been observed in most species around Chernobyl, except for wild boars. The wild boar paradox. Despite the expected decrease in contamination, wild boars have remained highly radioactive for decades, showing no significant reduction in cesium-137 levels. This puzzling situation appeared to break the laws of physics, as radiation in most other species like deer has decreased over time. Scientists were left wondering why wild boars were the exception. A breakthrough study in 2023 finally provided an answer to this mystery. The boars' radiation levels were not solely the result of the Chernobyl disaster. A decades-old source of contamination. Researchers discovered that the cesium-137 in wild boars is not just from Chernobyl. The contamination can be traced back to atmospheric nuclear weapons testing conducted by the Soviet Union in the 1950s and 1960s. Using a new method to detect the remnants of cesium-137 decay, scientists were able to determine that much of the radioactive material in the boars' bodies predates the Chernobyl explosion. This discovery revealed that the wild boars' high radiation levels are partly due to fallout from those earlier nuclear tests, which had long been overshadowed by the Chernobyl disaster. The role of mushrooms in the boar's diet. Another key factor in the wild boar paradox is the boar's diet. Wild boars in the region consume a large number of mushrooms, which play a crucial role in environmental contamination. Fungi, particularly those with deep mycelial webs, are highly effective at absorbing radiation from the environment, including from deep groundwater sources that are out of reach for most plants. These mushrooms have been soaking up contamination from the earlier nuclear tests and, more recently, from Chernobyl. By eating these contaminated mushrooms, wild boars have been consistently exposed to high levels of radiation. Conclusion. The wild boar paradox, once a baffling mystery, has been solved through a deeper understanding of the ecosystem and the role of historical nuclear events. The persistence of radiation in wild boars is not just a remnant of the Chernobyl disaster but a combination of nuclear fallout from decades past and the boar's unique dietary habits. This discovery underscores the complexity of ecosystems affected by radiation and the long-lasting impact of nuclear events on the environment.